Let's talk about pointers. Okay. So a pointer is another data type. It's a data type that holds a memory address of another variable. Pointer size is 4 bytes. Pointers give us more control of the memory management. We can use pointer to return more than one value from a function. We can use pointers when we need to allocate memory in runtime. Remember, as opposed to telling the compiler when we declare an array the exact size, when we use pointer, we don't need to do that. We can use pointer when we need to allocate memory in runtime, and we can use pointers to improve running time. And I'm going to show what does it mean to improve it and all of that. So let's look at the syntax. So the syntax is pretty simple. So let's say we want to have a pointer to an int. So the way we do it, we say int, we write int, and we put an asterisk after it, and then we give it a name. So let's see, a pointer to a variable from type int. So it will be int asterisk ptr. A pointer to a variable from type char will be char asterisk ptr. So basically, this is how we tell the compiler, I'm declaring a variable which is going to hold the address of int, of another variable of type int. It's not going to be an int, it's going to be an address of another variable that will be an int. So in another place in my program, I'm going to do int a, and I'm going to take the address of a and put it inside of that ptr. So that's going to point to that int variable address. A few things we need to know. Operator ampersand. When putting an ampersand before a variable, it will return its address. When we put in the asterisk before a pointer, we will return the content of the variable it points to. We're going to see example in a minute. And now this is a saved word we're going to use in uppercase. And we're going to say, what is it now? It's a constant expression that evaluates to 0. And when assigning a pointer to null, that means that the pointer doesn't point to any object. That means we're not assigning to anything, but we don't want the compiler to complain about it. We don't want our program to break. So it's a good practice to initialize pointers with null. That means that in that way we are saying we're not yet putting any actual value to it, but we do want to give it some kind of initializing value. So we put the null into it. Let's see an example. So, and we're going to do it together. You know what? Let's do it right here. Okay, so we have, let's look at our main. We are declaring an int x. We know x, right? We know int, I mean. It's a whole number. So we have x, and our x, we initialize it with 3. Then we are declaring a pointer that's going to point to an integer, and we're assigning it ampersand x. Let's look at the memory. Ampersand before a variable going to return its address. What is the address of x? 1000. So what's the value that the pointer is going to get? 1000. Very good. So px is going to be 1000. Okay? Now we are printing out px. What's going to be? Let's do this. We are printing out px. First we're printing out x. What are we going to print? X. 3. Very good. Now we are printing out px. It won't be 1000. That's right. And now we are printing out asterisk px. It's going to be the content of whatever it points to. 3. Very good. Very good. Okay, we got that. Pointers and functions. When passing pointers as arguments to a function, the address of the variable that the pointer points to is sent, right? Because pointer is an address, so we're sending an address. Any change made to the argument's content will affect the variable that was sent as the argument. By passing arguments by pointer to a function, we can return more than one value back. So those are two important things that are happening when we're using pointers as argument and inside of functions. So let's first talk about the first paragraph that I read. What I meant here is just like sending by reference, we are sending sort of a reference to the actual data, to the actual location. Because remember when I explained about the difference between sending by value versus by reference, I said when we're just sending a value of a variable as an argument, we're sort of sending just a copy of it. And the function itself going to allocate a new space for it, and we're just going to use the value. We're not really going to have any reference to the actual value. Remember the swap? So here it's like the same thing, but we're sending a pointer. That means we're sending another variable address. That means whatever we're going to change in that content of that address, it's going to keep the change that we did. That means whatever we're going to change in that function, for let's say swap or whatever function it is, it's going to influence the variable we've just sent its address. And we're going to do an example together, and we're going to have a better understanding, but that's what I'm trying to say here. That it's just like sending by reference, okay? And another thing, if I have this ability to send a variable as an argument, the address, okay, of a variable, and I know that whatever change that I'm going to do inside my function is going to be kept outside of the function, I can return more than one value. So in all of the functions that we did today, we did return something. We returned one value. What happens if we want to turn two values? So one way to do it is to send arguments by pointer, and those would be our return value, basically. But we're not going to send them back in return, because whatever the change that we're going to do, the function that called this function would use them as the result. So let's look at this line. Void find min max, and let's see what it gets. It gets an int, a pointer to int with the name min, a pointer to int with the name max, and array and its size. What do you think this function does?
It's fine. It's referencing the smallest value and the largest value in the array, and something about the size.
Well, we need the size if we want to go over the array to find the minimum and maximum, right? We have to know how long are we going to iterate for.
How large the array is.
Yeah. And what this function does, we're going to find the minimum value, and we're going to update the variable min. But this is just an address. So if we're going to update the content of this address, when we go back to the main, we can use it. We can say we know now the minimum and maximum of this array, and we didn't even use to do return value, return statement. You see, I put void. Void means no return. I just put the information that I wanted inside min and max.
What is the difference between, for instance, here int asterisk and int ampersand?
That's a good question. So the thing is that it's up to the compiler. So when we are sending, so here it's very clear. We're sending the address. When you're declaring that you're sending by reference, basically we are not sure what's happening under the hood. The compiler either can use pointers, or he can use other ways. It's kind of things that happens under the hood. We're not really sure how that's implemented, but this for sure is just address.
Okay. So it's explicitly
Yes.
say this, I want to send you address.
Yes, exactly. And not a preference. Okay, project 7 we're gonna do together. I'm gonna just open it and I'm gonna show you a nice feature in the builder that's very super helpful. So you don't need to type anything. I'm gonna do it, and I just want to show you. So let's make this the focus. Okay. So as you can see, my project 7 would be okay. Let's see it. It's this. We're gonna test pointers, but what I want to show you is how to use debugger. So to use debugger, first, what is debugger? So when we build a project, we can build it in debug mode or release mode. In general, debug mode is for developing when you're still in the development stage, and that's the release version. That's what we're sending up. But one of the things that we're getting when we're using in debug mode, that we can trace our code step by step and see what's happening. And that's a very useful tool. So the first thing and what I'm going to show you here, first I'm going to go over it and then I'm going to say how it. So I have 3 functions here. We have a function that testing, basically those 2 functions. And what I'm going to do is, what I want to see is what's happening here. You see, let's go over it. We are declaring a temp variable that holds this number. We are declaring a pointer to int that's gonna get the assignment of this function. And then we're gonna print out temp, and then we're gonna call another function on the content of P, and then we're gonna print out temp again. And what I want to know is what is printing. Now we can guess, but for this exercise, I want to go step by step, and we're going to see what's happened. So first thing, when we want to do this kind of operation and debugging our code, first we need to make sure that we are in debug mode. So in this here, we just to make sure that this is selected. Then another thing is we're going to toggle a breakpoint. Toggle a breakpoint, that means we're telling the builder, I'm going to put a point that you're going to stop there. Don't execute the entire code. Execute everything until that point and stop. Because from this moment, I'm going to take over and I want to run line by line my code. So let's put a breakpoint right here. Okay, you see, I just added it. Another way to do it is here, add a breakpoint, and just use this. Okay. Now I'm gonna run not this for release. We're gonna run this. And did it stop? No. Oh, it did stop. I'm sorry. And you see where we are? That means we are here. And I want to add here, see this watch list? I want to add values to watch. So I want to do, how did you do it, Al? Just to,
so if you select the variable you want to watch,
yeah,
highlight it, and
yeah,
in the watch list, right click and watch. The white area underneath it. Add a watch on top. So it knows what you have highlighted.
right.
This temp variable to be watched. Every time that temp variable changes, you see its value in this watch list.
And I want to do this as well. Okay. So another way to do it is just from the run, add a watch. Okay, this is just, I'll just show that like shortcuts. Okay, and now how do I go step by step? So as you can see here, I have those 3 buttons. So this one is say step over, this one's trace into, and this one run until return. So when we're gonna want to do step over, that just mean go to the next line. So this line we just do an assignment. So let's go to the next one. You see, here we are. Now I want to know what this function does. Let's go inside this function. We need to go inside, trace inside. And here we are. So let's add another thing. We are sending y, and we're sending it by reference. So that means whatever change we do here is going to influence whatever we sent. And what did we send? We send the temp. So whatever change is going to happen to y, the temp is going to change. Okay, let's just add here the y as well. So let's see, can I do this? Okay, so we are here. Let's move on. Let's go step by step. So let's see what this line is doing. We're taking the y, which is 1234, and we are dividing by 100, and we are adding the modulo 10. So let's think, what should it be? So it's a whole number, and remember we did it today. So modulo 10, what would give us? The number is 1, 2, 3, 4. 4. And we are going to add it to 1, 12. 12 plus 4 is 16. Let's check what it is. Oh, and that's what it gets. But what are we going to return here? The address. So 2 things are going to happen. We're going to return the address, but also, what do you expect to happen to temp? Because this is the one we send in. And you can see the answer right there. But let's see. So P got the address. This is the address. And temp was changed to 16 because we send it by reference. Let's move on. Now I want to go into the foo function, but let's first see what are we sending here. We are sending asterisk P. So P is pointing to temp. We are putting the asterisk before it, which is going to get the content. So that's going to be 16. Let's go inside that function. Let's see. Let's add this X here as to our watch. Okay, so X is 16. We're sending it by reference. That means whatever we send in gonna be influenced. So let's go again to the main for a minute. It's not the main calls this function. We are sending asterisk P. If P is pointing to temp, well, right now it's undefined because we're inside of a function. But as you remember, temp was 16. So whatever we're going to send here, because we're sending by reference, going to be influenced. So temp is going to be influenced. That's what I'm trying to say. Now let's see what is happening here. That's interesting. We didn't see that today. What is x modulo 2? That's true. Why?
There is no remainder.
That's right. Remember, modulo gives us remainder. So 16 divided by 2 is 8 with no remainder, so 0. And we're going to add a 10, and we're going to assign it to x. So let's go move on. X get 10. And whatever we send is going to be influenced, right? Let's move on then. And then temp is 10. So let's see what we're sending. And so this is what we are printing out. So this was just a demonstration. That's a hard thing to do, like alone, and especially in beginner stage, but this was just like to show you the power of dealing with addresses. Okay? So let's stop it now. This is how you stop the debugger.
The debugger is very powerful, so you added the debugger now, but if you want to view debugger options, you see all these other options you can do with the debugger. You get a full call stack trace, so when you're deep in debugging and you're not sure what's wrong, you need a good debugger to get inside the code to see what's going on.
Do you want to show something here from the debugger? Is there something?
I think I did more than enough for now.
Okay. Okay. Good. So, and it's very, very helpful, as Al said, because when you, yes,
Don't it used to used to keep the memory down,
what again?
or don't it used to keep like decided using all, like if you were to call by variable, you would know what take up more memory.
Yes. So as regards to being more efficient in our programming, think about it. When you have like big data and you're sending its value, it's going to take a long time to send this value. So one of the power of sending just an address, you can have like 1,000 integers array, but well, this is still small. But just to illustrate, if instead of sending the entire thing to copy to your function, you're just sending a reference to the address, you're just sending 4 bytes instead of a big thing. So that's definitely going to influence our efficiency of the program. That's a good point.